Hello students, how are you? I hope all of you are good. In this video, I am going to discuss the next concept in the chapter differential equations. That is what? General solution and particular solution of the differential equation. So firstly, to know the general solution and particular solution of the differential equation, first we should know what is meant by the solution of differential equation. So let us consider one of the polynomial equation. So first we know what is meant by the solution of the polynomial equation. Then we go for the solution for the differential equation. So let us consider one of the polynomial equation in which one of the linear equation, that is x plus 9 is equals to 0. So observe this equation. If I substitute the value of x is equals to minus 9 in this equation, so minus 9 plus 9 which is equals to 0. So if I substitute the value of x minus 9 in the LHS of this equation, it gives what? Value of RHS. It means x equals to minus 9 is a solution of this equation. X equals to minus 9 is solution of this equation. So solution means the values of x which satisfies the equation are called as solutions of the equation, Solutions of the equations means the values of x which satisfies the given equation are called as what? Solutions of the equation. So in the similar way, solution of the differential equation means let us consider one example. See here. So to understand briefly the solution of the differential equation, let us consider one example. Suppose y is equals to one of the solution a sin x plus b cos x. And by differentiating this solution, dy by dx is equals to derivative of a sin x is a cos x plus derivative of b sin x, b as it is, derivative of cos x is minus sin x. And again differentiate this second derivative, d square y by dx square is equals to derivative of a cos x is minus a sin x minus derivative of b sin x is b cos x. So now in this second derivative d square y by dx square, I just take the common minus, remaining what? A sin x plus b cos x. So observe here, the term inside the bracket is it equal to y. So therefore, in the next step, I am going to replace d square y by dx square is equals to minus of y. So finally, we got d square y by d square y divided by dx square. E minus y na inside to plus y is equals to 0. Observe here, y equal to a sin x plus b cos x is one of the function, and by differentiating this function, we got d square y by dx square plus y equal to 0. By what? Differentiating. By differentiating. By differentiating, we got the differential equation. Now see here, if I substitute the value of second derivative minus of a sin x plus b cos x and the value of y a sin x plus b cos x in this differential equation, then definitely this y satisfies this differential equation. Definitely this function y satisfies this differential equation. It means this is a solution of this differential equation. So solution of the differential equation means a solution which satisfies the differential equation. A solution which satisfies the differential equation is called as solution of the differential equation. I hope all of you understood. Now, what is meant by this general solution and the particular solution? Observe here, for this differential equation, y equal to a sin x plus b cos x is a solution. But in these solutions, a and b are the arbitrary constant, are the arbitrary constants. Arbitrary constants means any constants. Arbitrary constants means any constants. Any constants means you can take any fixed value for a and b. So I can write y is equals to a in place of a. I am going to take one of the fixed value. So y is equals to 2 sin x plus b is 3. So 3 cos x. So this y equal to 2 sin x plus 3 cos x is also one of the solution of this differential equation. Or one of the students takes the value of a and b. A is equals to minus 5 and b is equals to 10. Then y is equals to minus 5 sin x plus b cos x is also solution of this differential equation. As we changes the values of a and b in this y, we are going to get the new solutions of the differential equations. I hope all of you understanding. It means in general, the solution of this differential equation, we can write it as y is equals to a sin x plus b cos x. Hence, the solution of the differential equation which involves these arbitrary constants, are called as general solution of the differential equation. Are called general solution of the differential equation. General solution means a solution which involves arbitrary constants. A solution which involves arbitrary constants are called as general solution of the differential equation. And what is meant by this particular solution? Particular solution means, you observe here. Here the arbitrary constants are replaced by some fixed values. Here the arbitrary constants in the solution, in the general solution, are replaced by the constant values. It means the solution which is free from arbitrary constants is called as particular solution of the differential equation. I hope all of you understood. Particular solution means a solution which is free from the arbitrary constants is called as a particular solution of the differential equation. I hope all of you understood. We got the differential equation from the solution by differentiating. And to find the solution of the differential equation when differential equation is given, if suppose his question is, if d square y by dx square plus y is one of the different, y equal to 0 is one of the differential equation, then find its solution. So definitely we know that solution of this differential equation is y is equals to a sin x plus b cos x. But how we got this solution from this differential equation? So to get the solution of this differential equation, we need to integrate this differential equation. As you know that integration is a reverse process of differentiation. Solution differentiate ಮಾಡೋದ್ರಿಂದ differential equation ಬರುತ್ತಾ. In the same way, differential equation integrate ಮಾಡೋದ್ರಿಂದ solution ಬರುತ್ತೆ. I hope all of you understood what I am saying here. And one more thing I would like to discuss here. So here the function is a sin x plus b cos x, and the differential equation is d square y by dx square plus y equal to 0. So why we not call this dy by dx is a respective differential equation of this y? ನಾನು ಇದೇ ಫಸ್ಟ್ ಆರ್ಡರ್ ಡೆರಿವೇಟಿವ್ಗೆ ಡಿಫರೆನ್ಷಿಯಲ್ ಇಕ್ವೇಶನ್ ಆಫ್ ದಿಸ್ ರೆಸ್ಪೆಕ್ಟಿವ್ y ಅಂತ ಹೇಳ್ಬೋದಿತ್ತು. ಯಾಕೆ ಹೇಳಿಲ್ಲ? There exist some key points. That key points is nothing but, in this solution we have totally two arbitrary constants. In these solutions we have totally two arbitrary constants, a and b. So that's why we need to differentiate this solution two times to get the respective differential equation. I hope all of you understood. The key point is here, order of the differential equation. Order of differential equation. Order of the differential equation should be equals to number of arbitrary constants in the solution. Number of arbitrary constants in the solution of the differential equation. So important point, we need to differentiate y for how many times? The number of times of derivative or differentiating a solution should be equals to number of arbitrary constants in the solution of the differential equation. I hope all of you understood. So now let's start the solving the differential equation. So in your syllabus there exists only for solving the first order first degree differential equation. So as you know that this is what one of the second order differential equation. So that's why I'm not going to solve this differential equation. So in your syllabus, for your syllabus, the syllabus is what? Solving the differential equations which are only first order first degree differential equations. And for your syllabus, totally there exist three methods to solve the first order first degree differential equation. In that the first one is variable separable method. First one is what? Variable separable method. And second one is a homogeneous differential equations. And third one is a linear differential equations. So in this video, I am going to discuss the solving the first order differential equations by using the variable separable method. So let us consider one example. Find the general solution of the differential equation. Let's say dy by dx is equals to 1 plus x square divided by 1 plus y square. So now we need to solve this differential equation by using what? Variable separable method. So important concept. From this concept you are going to get 2 mark questions in your annual examination. ಇದಕ್ಕಿಂತ ಬಿಫೋರ್ ಆಗಿ ಈ ಮೆಥಡ್ಲಿಂದ ಯು ಆರ್ ಗೋಯಿಂಗ್ ಟು ಗೆಟ್ 3 ಮಾರ್ಕ್ ಕ್ವಶನ್ಸ್ ಪ್ರೀವಿಯಸ್ ಆಗಿ. ಬಟ್ ಈ ಸಲ ಏನು ಮಾಡಿದರೆ ಸಿಲೆಬಸ್ ಅಂತೂ ರೆಡ್ಯೂಸ್ ಆಗಿದೆ. ಸೊ ದಟ್ಸ್ ವೈ ಫ್ರಮ್ ದಿಸ್ ಚಾಪ್ಟರ್ he is going to ask 2 mark questions from this variable separable method. And let's say here variable separable, name itself indicates separable. We are going to separate what? Variables. So we need to separate the variables to solve this differential equation by using this first method. In this differential equation, the variables involved are x and y. In this differential equation, the variables involved x and y. So first we need to separate x and y either side of the equal sign. So it means first I am going to take this 1 plus y square towards the right side. So 1 plus y square into nodri ಏನಾಗುತ್ತೆ dy equal to 1 plus x square into ಈ dx na right side ತೋರಿ multiplied with dx. Now the variables are separated here. dy one side ಆಯ್ತು, dx one side ಆಯ್ತು. As you know that to find the solution of the differential equation, we need to integrate the given differential equation. So after separated the variables to identify its solution, we need to integrate on both sides. What is the next step? Integrate on both sides. So integrating on both sides. So integration of 1 plus y square dy is equals to integration of 1 plus x square dx. Now to find the solution of the differential equation, so we must and should perfect the integration. So as you know that integration of 1 dy is y plus integration of y square is y cube divided by 3 equals to integration of 1 dx is x plus integration of x square is x cube divided by 3 plus c is the answer. Where this c is a arbitrary constant. This c is what? Arbitrary constant. So if you replace c by any other fixed values, we got one other solution of this differential equation. It means this y plus y cube by 3 is equals to x plus x cube by 3 plus c is one of the general solution of this given differential equation. General solution of this given differential equation. I hope all of you understood the solving differential equation using the variable separable method. So let's start some of the questions from your NCERT textbook. Here is the first question. Find the general solution of the differential equation dy by dx is equals to 1 plus x square into 1 plus y square. So this is similar to the previous one. See here, to identify the general solution of this differential equation, first thing we need to separate the variables involved in this differential equation. The variables involved in this differential equations are y and x. So let's take y and x on either side of the equation. So here dy is exist. So dy, shift this 1 plus y square to left side. It becomes what? Dy divided by 1 plus y square equals to 1 plus x square into dx na right side shift madri multiplied by dx. Now here we separated the variables on either side of the equal sign. So after separating the variables, in the next step, we need to integrate to get its solution. So what is the next step? Integrating on both sides. Integration of dy divided by 1 plus y square is equals to integration of 1 plus x square dx. I hope all of you are understanding. Now see here, as you know that integration of 1 dx is x plus integration of x square dx is x cube by 3 plus c. And to integrate this dy by 1 plus y square, here we have one of the standard integration formula. That is what? Integration of dx divides 1 plus x square is equals to tan inverse x plus c. So by using this formula, integration of dx divided by 1 plus y square is equal to here the variable is y. So tan inverse y, and which is a required general solution of the given differential equation. I hope all of you understood. Let's start the next question. And the next question is, find the general solution of the differential equation dy by dx is equals to 1 minus cos x divides 1 plus cos x. So first separate the variables. So in this differential, first I am going to write the given differential equation. The given differential equation is dy by dx is equals to 1 minus cos x divides 1 plus cos x. So observe this differential equation. This equation also consisting the variables x and y. So first separate the variables. Simple. On RHS only the function involved with the variable x. So just shift this dx towards the right side. We got what? Dy is equals to 1 minus cos x divides 1 plus cos x dx. So we separate the variables. So after separating variables, we need to integrate on either side of the differential equation. So like integrate on both sides. It means integration of dy is equals to integration of 1 minus cos x divides 1 plus cos x dx. So as you know that we know the formula for 1 minus cos x. So integration, to integrate this first we need to simplify. We need to convert this integrate to the what? Easily integrate form. To what? Easily integrating form or integrate form. Integrate form. To convert this easily integrate form, we need to use some trigonometric identities. As you know that 1 minus cos x is 2 sine square x by 2 divide by, and 1 plus cos x is 2 cos square x by 2 with respect to x, and on LHS integration of dy as it is. Now on RHS, here I can cancel 2 from numerator and denominator. So finally we got Finally, we got integration of dy is equals to integration of sin square x by 2 divided by cos square x by 2 is a tan square x by 2 with respect to x. Again, tan square x by 2 is not easily integrate form. So first we need to convert to integrating form by using the basic identities of the trigonometric functions. That is what integration of dy is equals to integration of, by using the golden formulas, secant square x minus tan square x is equals to 1. By this formula, tan square x can be written as secant square x minus 1, which is equals to what? Tan square x. See, 1 I could 2 mandiri minus tan square x is set. So therefore, in this integration of tan square x by 2 can be written as a secant square x by 2 minus 1. Secant square x by 2 minus 1 with respect to x. I hope all of you understanding. Now see here, integration of dy is y equals to integration of secant square x by 2 is tan x by 2 divided by derivative of x by 2 is 1 by 2 minus integration of 1 dx is x. Therefore final answer is y is equals to, shift this 1 by 2 towards numerator, it becomes what? 2 tan x by 2 minus x plus integral constant c, and this is a required general solution of the given differential equation. I hope all of you understood. Next, start the next question. And the next question is, find the equation of curve passing through the point minus 2 comma 3, given that slope of the tangent to the curve at any point xy is 2x divided by y square. So one of the important question asked in the year March 2020. And see here he has no given any differential equation, but he has to given some information. From that information, we need to form the differential equation first. So in this question, he has to given that slope of the tangent. So slope of the tangent mathematically denoted by what? Dy by dx. So slope of the tangent dy by dx to the curve at any point xy is equal to what? 2x by y square. Therefore, dy by dx is equals to 2x by y square is the given differential equation in this question. I hope all of you understood how to form a differential equation by using the given information. And next, directly we got one of the differential equation here. So what is the next step? We need to solve this differential equation by using the variable separable method. As you know that in this differential equation also variables y and x are involved here. So first separate the variables. It means separate y and x on either side of the equality sign. See here, first shift this y square towards the left side, it becomes what? Y square dy equal to dx towards the right side, 2x dx. I hope all of you understood. And what is the next step after separating the variables, integrating on either side? So integrating of y square dy is equals to integration of 2x dx. So we know that integration of y square with respect to y is y cube divided by 3 equals to integration of 2x. 2 is constant taken outside integral side. Then integration of x is x square divided by 2 plus the integral constant c. And now y cube is equals to, see here, y cube divided by 3 is equals to, here I can cancel this 2 from numerator and denominator. We got x square plus c, call it as equation k. See here he has to given one more information here. What is that? The required curve passing through the point minus 2 3. So what is the next step? We need to substitute the values of x and y. So this required curve, since required curve passing through, required curve passing through which point? Minus 2 comma 3. So let's say minus 2 is a value of x and 3 is the value of y. So substitute the values of x and y in this equation case. Here what we got here, y cube means 3 cube, the value of y is 3, 3 cube divided by 3 equal to x value is minus 2, so minus 2 square plus c. So by using this, the value of 3 cube is 27 divided by 3 equal to minus 2 square is 4 plus c. And here I can cancel 3 ones are 3 nines are. So 9, shift this plus 4 towards left side, minus 4 is equals to c. So we got 5 is equals to c. I hope all of you understood. By the given values of x and y, we got the value of c. Now substitute this value of c in the equation k. What is the next thing? Equation k implies, substitute this value of c in equation k. Equation k implies y cube divided by 3 is equals to x square plus value of c is 5, plus value of c is 5, and this is a required particular solution. Observe here, in the equation case c is involved, where c is called as a arbitrary constant. So this arbitrary constant is replaced by 5, therefore this solution is free from the arbitrary constant. That's why this is called as one of the particular solution. So or you can simplify this also in next step. See here, so to get the value of y, to get the value of y cube is equals to 3 into x square plus 5, and then y cube is equals to 3x square plus 3 into 5, 15. Therefore y is equals to 3x square plus 15 power 1 by 3 is a required particular solution of this differential equation. I hope all of you understood. Let's start the next question. And the next question is, find the equation of the curve passing through the point 1 1, given that slope of the, slope of the tangent, slope of the tangent to the curve at any point xy is x by y. So this is also one of the important question asked in the year March 2016. And this question is also similar to the previous one. Here in this question he has given, observe here, in this question he has given slope of the tangent to the curve is what? X by y. It means dy by dx is equals to x by y. I hope all of you understood. So we found a differential equation from the given information. What is the next step? Separate the variables. So here, shift this y towards the left side and dx towards the right side. It becomes what? Y dy is equals to x into dx. So we separated the variables and then integrate either side of the equation. Integration of y dy is equals to integration of x dx. As you know that integration of y dy is y square divided by 2 equal to integration of x is x square by 2 plus c. And let's say this is equation k. And he has given one more information in this question. What is that? Required curve passing through the point 1 comma 1. So therefore, what is the next step? This curve passing through, passing through which point? 1 comma 1. So where x is 1 and y is also 1, this is the value of x and y. Substitute the values of x and y in the equation k. So next step, equation k implies value of x is 1, value of y is 1. So y square means 1 square divided by 2 equal to x square is also 1 square divided by 2 plus c. So finally we got 1 square is 1. So therefore 1 by 2. Shift this 1 by 2 towards left side. Minus 1 by 2 is equals to c. So 1 by 2 minus 1 by 2 is 0 is equals to c. So we got the value of c is 0. Now substitute this value of c in equation k to get its particular solution. So now what? Equation k implies y square by 2 equal to x square by 2 plus c is 0. Therefore, y square by 2 is equals to x square by 2. Now cancel 2 on either side. So finally we got y square is equals to x square or y square minus x square is equals to 0 is the required particular solution of this differential equation. I hope all of you understood.